Hello, everyone. I'm doing fine. How are you? Well, class is kind of empty today. Class is kind of empty today. Yeah. Okay, I have your exam, but I'm gonna give you the exam after half an hour when more people come. I hope to see more people. Yeah. And it wasn't actually better than the last exam. The same amount. Half failed, half of the class failed, half passed. Yeah. So after I give you the exam, I'm going to show you a grade book, not grade book, grade calculator. I didn't show you the grade calculator, right? I did? No, I didn't. So I'm going to show you the grade calculator. You can calculate your own grade, or you can have an idea about your future grade based on your exam 1, 2, and the 4 quizzes I have. I also have a quiz number 4. And last day to drop this class is November 6th. So if you see there's no way you can pass, especially if you didn't do my MATLAB homework and quizzes, even after I told you so many times, then you guys actually have no hope of passing this class. Okay. So if you see there is no hope, then you can drop before November 6th. Okay. Okay, but if you don't want to drop, then you have choices. Go to tutoring a lot, improve your next 2 exams. We have third exam and the final exam, and have your MyMathLab score as high as possible, especially the homework. You can have 100% the homework. So have 100% the homework and quiz. Try to have as high as possible. If the MyMathLab score is high, even if you fail the in-class exam, 1 or 2 of them, you can still pass with a D. Okay, so if you just want to pass and you can earn D, then you shouldn't drop. You can stay, you can get you D. And if you're looking for some better grade like A or B, then see what options you have. Any question before you start? Any comments? Concern? I mean, you're going to tell me concern later. Any complaints so far? No? So we are done in chapter 12, sorry, chapter 11. And I feel like I didn't do what problem on chapter 12, right? We didn't do any word problem on chapter 12. Not 12, sorry, 11, quadratic. But I thought I saw some question in the final exam, the real life application of quadratic, even though we don't have that in our syllabus. Our syllabus is so weird. Like, they don't have many things in the syllabus, but they give questions from outside of the syllabus. So once I asked the department, like, why is this? Like, we don't have these sections in the syllabus, but they have questions in the final exam. And they told me, well, it's a prereq knowledge. They're supposed to have the knowledge. Really? Yeah. I'll see if we have what problem for quadratic. If we do, then I'm going to go about what problem. But for now, chapter 12, which is more fun, I believe, than chapter 11. Chapter 12 has many sections, and we are going to do all the sections in chapter 12. And then from chapter 13, there will be only 3 or 4 sections. So your next exam will be when you come back from Thanksgiving break. So end of the November or beginning of the December. And the materials, definitely chapter 12. And in the last exam, I didn't put anything from 11.5 and 6. Did you notice? I didn't put anything from there. So I'm going to put 11.56, chapter 12. And let's see if we can finish chapter 13 or at least start chapter 13 before Thanksgiving. Then it will be part of chapter 13. Okay, any final exam will be 16. December 16, Tuesday, 8 a.m. in the morning, if I'm not wrong. Let me just make sure again. So October, from tomorrow, it's November. December 16, yep. Our last day of class is 15, but 15 is a Monday. We don't have class on Monday. So for us, our last day of class will be 12, Friday. And then your final exam will be on 16th. It will be a different room. I'll tell you the room number later. Okay, chapter 12. We are starting with composite function. The composite function, it means you have one function and you're setting another function inside that function. So when you add, we just add two functions. When you subtract, we just subtract one from another. When you multiply two functions separately. Same thing, division, you do it individually. I'm not individually combining, but here it's totally different than addition, subtraction, multiplication, division. It's like you're putting something inside another thing. It's like a pillowcase. You have a pillowcase and you are putting pillow inside the pillowcase. So pillow combining with pillowcase is a composite function. Our body is a composite function. Our body itself is a function we put on our clothes. So it's a composite function. So composite function works this way. You have one function, put inside another function. Now let's start with a basic one. Let's say you have a function. Let's say the f function square root, and you have a g function x squared plus 1. So the composed function f of g of s. The way we read this is as this, f of g of x. This expression is same as this weird looking thing. They're the same thing. Some people like to write f of g x, and then the normal way, like the way I like to write is f of g of x. But it doesn't matter which format you see, remember they're the same thing. What does that mean? It means whatever function you have inside, that function you are putting inside the outer function. So inner function is g, your outer function is f. So you go to the f function first and write out the structure of the f function. Our f function is square root of x. So when you put g inside f, you don't write x for the f function. Instead of the x, you write the entire g function in here. So this is what it means putting one function inside another one. The outer function has a structure, but the inner x is not x anymore, it's the g function. We can also do the other way around. We can do g of f of x. So we call it g of f of x, which is same as gof of x. These two expressions are same. So in this case, we have our inner function as f. So you're putting f inside the g. So you write out the g function structure. Our structure for the g function is x squared plus 1. But instead of the x, you erase the x and you write the f function, which is square root. Okay. And then we do algebra to simplify, but this is what it means to compose to function. Any questions so far? It's not too bad, right? So let's do more example. Let's say we have f function as negative x squared plus 1. And g function is 2x minus 2. There are two different functions. But first, we are going to find f of g of x. It means you write out the structure for the f function. So what is our f function? Negative x squared plus 1. Mm-hmm. 2x minus 2. What do you mean? Oh, it depends on their mood. Whatever they like. So I'm showing you both. Like, I don't know which one they will put. Sometimes they put the f of g, like FG version, and sometimes they put fog. So the simpler way we can read the first version is called fog of x, and the other one is gulf of x. But it sounds weird, like fog, gulf. So I prefer the other method. It looks nicer. So the composite function is done. Now, if you want to simplify, you can FOIL them out and then combine them. But since this question doesn't have the direction simplify, it's just find this. So for now, you can just stop here. Now let's find the other one. What if you put fg inside the f function? So this time, inner function is f. Oh, let me change the color. Did you see the blue and yellow? It made green. It always amazes me, like, oh man, it's so cool. Do you know how to make pink? Pink comes from which two colors? Pink, in real life, pink. Red and white. I didn't know that until I took a painting class. Oh man, the more red you put, the darker pink it becomes. The less pink you put in white, the less lighter pink color it comes. And it was so cool. In the store, they didn't have any pink color, but we already got to use pink color. So I was wondering, like, how can I get pink color? And then I saw a teacher, he did the combination. I was like, oh, so cool. The color combination always makes me like amazed me. Okay, so what we are doing here, which function is supposed to write first? G. So what's the structure for the G? 2x minus 2, right? Once you write the G function, erase your x. Instead of x, what do we write? Negative x squared plus 1. And simplifying this one is easier. So let's simplify this time. Even though they didn't mention to simplify, but let's see what happens if you do simplify. So if you want to simplify, what is our first step to do? Distribute. So we get negative 2x squared plus 2. And we have our minus 2. And then what do you see? They cancel out. So it's simply negative 2x squared. We could simplify the first one, but I'm too lazy. So just left it alone. Any questions so far? Is there anybody who is lost, have no idea what we are doing? No? Okay, then try the next one. We have f function as square root absolute value of x, and g function as 6x minus 8. Find both of them, f of g and g of f. And here you actually cannot simplify. You just substitute and you're done. Ready? Ajmai, would you like to try the first one? F of G.
F and then for GPU, right? For the parentheses.
Mm-hmm.
And then you plug in 6 minus 8 for the f of x equals absolute value of x.
So it goes inside the absolute value. So F function, so we have G function that goes inside the F. So F is the absolute value, G is 6x minus 8. So you simply put 6x minus 8 inside the absolute value. Showing, right? Or showing. Would you like to try the next one? G of F. So which function is supposed to write first, the F or the G? G. So we have 6x minus 8. And then what do you do? Not combine. We erase the x in the G function. Put the F function instead. So what is our F function? Absolute value of x. So G function, but there will be no x. Instead of x, we're going to have the entire F function. And that's it. That's all we need to do. More example. Oh, no. I mean, we do have more example, but it's a little bit more than just example. So we know how to compose function. And now they want us to evaluate the composite function at some x value. So there are two ways of doing it. First, you can find the composite function by putting one function instead of another one, and then substitute x with the number. Or if you don't want to work with the composite function, then you can simply work with the numbers. First, you can find the inner function. So evaluate the inner function at the given x value. You're going to get a number. Whatever number you have, substitute that into the outer function. So here we have our inner function g of 2. So first find g of 2. We have g of x as 2x plus 2. So g of 2, it means 2 times 2 plus 2. And what is that? 6. So now they want us to find f of g of 2, but we just found what is g of 2. So this is 6. And now it's easy, right? Basically, we are finding what is f of 6. So we go to the f function. Our f function is x squared plus 5x. So what is f of 6? 6 squared plus 5 times 6. And what is 6 squared? 36. 5 times 6? 30. So total is 66. This is the shorter version of the composite function. The longer version is first find the composite function by working with the function themselves, and then evaluate the number with given x values. But if you use this method, you don't have to work with the functions. You only work with the numbers in each function. Any question? Then you go ahead and try the other way around. What is g of f of 2? Do you think you're going to get the same number? Good. So you do know some logic. Ready? Kathleen, would you like to help me with this one? G of f of 2. Which one you find first? F of 2. So we have f of x is x squared plus 5x. Then what is f of 2? 2 squared plus 5 times, which is 4 plus 10, 14. And then what do you do with this? The g of f of 2 means g of, not 2, sorry, 14. Because we just found this thing is actually 14. So how do you find that, g of 14? Two times 14 plus 2. Perfect. So what do you get? Do you know what is 2 times 14? It's 14 plus 14. 28. So it's 30. Any question from anyone? Are you guys sure that there is no question? This is a final exam question. You're going to see at least one of these in the final. And definitely in the in-class exam. Okay, one more. Find f of g of 1 and g of f of 1. Maybe 1. And Ashley, Jelisa, Michael, Letty, Lola, Jonathan, Reina, Denisa, Samantha, Nicole, Andy, Leah, Andrew, George, Mariana, Fatamata, Daniel is absent. Ajmain, yeah, showing, Chloe, Ethan, Catherine here, Brennan here, Raim, Shahana here, Leonardo, Brian R, Brian V, Gian, absent, Alex here, Anastasia, absent. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 people absent. Really, for Halloween?
Yeah. like some professors, they cancel the classes. So maybe the people who have like,
Oh.
like their.
Wow. Interesting. Okay, any volunteer for this one? For F of G? Mariana, go ahead.
One. Gonna first, we're gonna put one into the G function, so x plus
The
three.
G of X is X plus
Which
3.
equals 1 plus 3, which is 4.
Mm-hmm.
And then we're gonna take a function, which is x squared minus 2x plus 3. And instead of x, we're gonna add the 4 into it, which is gonna be 4 squared minus 2 times 4 plus 3, which equals to 16 minus 8 plus 3, which altogether is 9.
No, not 9.
Oh,
16
not
minus 8 is 8.
Yeah.
8 plus 3,
Plus, yeah, 11.
11.
I don't know why.
Pinky, we got it. So this is 4. Okay, it's on smoothly. Now the other one. Who would like to try G of F of 1? Brennan. Mm-hmm. Mm-hmm. So F of 1 means 2. So you find, what do you say? 2 plus 3, which is 1. Good job. Any question? Is there anybody who is still lost? Please don't be shy. You are in trouble if you are shy. You can see your grades after a few minutes. Okay, one last question. Let's try both. Find this and G of F of -1. Ethan, the first one. F of G of -1. Which one we first find, F or G? Whatever is inside. So what is inside? We have F of G of -1. So which function is inside? The G function or the F function? G function. So you're going to go for the G function. So what you are finding? We have G of X, 2x plus 5. So what do you have to find now? G of -1. So how much is G of -1? Two times -1 plus 5. So what do you have? -2 plus 5. 3. So f of G of -1 basically means f of what? What is G of -1? 3. So basically you're finding what is f of 3. So how do you find f of 3? No, what is our f function? Three square plus 2 times 3. So what do you get? And what is 9 plus 6? 15. Good, you got it. Any question on this one from anyone? Reina, the next one. We have x squared plus 2x. That tells us -1 is -1 squared times 2 times -1. And what do you get from here? 1 minus 2, which is -1. Great. So what it tells us? Mm-hmm. Mm-hmm. So -2 plus 5, that gives us 3. Perfect. Got it. Any question from anyone? Any complaints so far? Okay, so now we have became an expert in this. So when you see this question in the exam, I hope you can ace it. Also in the final exam. Now we are going to the same thing, but this time instead of using two function, we use the graph of two function. The first function is f, the second function is g. And we are going to find both of them. F of g of 2 and g of f of 2. So f of g of 2, which function is inside, the f or the g? G. So we're going to first find g of 2. So which function is g, the left or the right? So in the right function, how much is g of 2? What is this 2, the x value or the y value for the g function? X. So this is the 2 for x, 2 for g function. For the x value 2, what's the y value? 5. So this thing here is 5. So we are now finding what? F of 5. So f is the first function. What is this 5? The x value or the y value? X value. So this is actually 5 for the f function. So if you go up here, what's the y value? And that's it. Here's our answer. No math is needed. We're just observing and finding the answers. So always start from the inner function. Whatever is inside, find that function. Put the result into the outer function and get the new one, the new number. Shahana, would you like to do the next one? G of f of 2. So when x is 2, in that function our y is 4. So this is 4. This is 4. So when you go here, this is also 4. These are for your homework. So you will see this type of question in the homework. Any question? Is there anybody who is lost yet? No one? Are you sure? Now the fun part. Decompose them. So it's like you're given the pillow in the case. Now uncase them. Okay? Put the pillow and case separately. Which one is pillow and which one is case? Find out that. So we are given a composed function. 2x squared minus 6. So we have, they're saying f of g of x is square root of 2x squared minus 6. Which one is your f function and which one is your g function? Any idea? George, would you like to try this one? You don't know? I thought you know everything. Alex. So you want g function to be x squared, okay. This is one, good. But this is not the only solution. Good one. So what he did, he said, well, is your inner function is g? So whatever is inside, that should be a g function. So he saw x squared is inside. So he said x squared is my g function. That means if you erase the x squared and replace with x, the rest should be the f function. But there's another one.
G of x would be 2x squared minus 6, and f of x would be square root of x.
Perfect. See, same composite function, but there are so many compositions. So what he saw was the entire thing. Let me change the color. The entire thing is the g function, which is inside. That means if you replace this entire thing with x, whatever remains, that's your f function, the outer shell. So we have multiple correct answers. It will not be in the final, but it will be in the exam. I love this type of question, composition. So I'll put at least 4 of these in the exam. Next one. They gave us F and G, and they gave us a combination. You have to find out what is this composition, F of G or G of F. So they are saying our F is x squared minus 3. Our G is 5x. And somehow their composition is 25x squared minus 3. What is this composition? F of G of x or G of f of x? Which one is correct? F of G? Why do you think it's F of G? So if you do F of G, you are putting G inside the F.
Minus 3 and then.
So X or F function is X squared minus 3. And putting G inside means you're erasing the X and writing 5X. So if you simplify, you get 25, which is 5 squared, X squared minus 3. Yep, the correct answer is F of G of X. If you're not sure, you can just guess one and then find out it's correct or not. Like that I did. She said it's F of G, and then we checked it's correct or not. And we found it is correct. Any question? More fun. The first one, they told us it's F of G. So this thing is F of G of X, which is X plus 4 whole thing to the power 6. What is G of X and what is F of X? Fatimata, would you like to try this one? Both.
Okay, I'm thinking four.
But doesn't it look weird without any variable? So you put X here, X to the 6. So if you erase your inner function, whatever remains, that's the outer function. But if you don't have any variable at all, it looks so weird. So replace your empty space with the variable X. That's the outer function. Which is same as X, just X to the 6. Not square, it's X to the 6. It doesn't have any square, right? The inner function is whatever you have inside. So the G is easy to see. The inside function is always whatever is inside. So in here on the left, we have G function inside. That means on the right, whatever we have inside the parentheses, that must be the G. So if you erase your G, we're left with parentheses to the power 6. So you replace the empty space inside the parentheses with X. So it's X to the power 6. The next one says, this thing is the other way around. It's G of F of X. So what is F and what is G? George, do you know this one? What is F? X minus 4 square root of X plus 6. Perfect. But this is not the only way of only F and G. Anyone wants to try any other way of finding F of G? F and G? Never mind. It doesn't have square, so it wouldn't make sense. It looks like it. I was thinking of X. If it was an X square, then the X square would be the inner function and the rest would be the outer function. But now it's X. The last one. This is also G of f of x. So what is f of x and what is g of x? Michael, would you like to try this one?
Squared plus x minus 4.
Good.
X is
If you erase that from the formula, what is left?
x squared plus 6.
Square root.
Yeah, squared.
Oops. How did you get error? So square root and plus 6. But there is no variable here, right? So you have to put a variable. Where do you put the variable? Where?
Inside.
Good job. Whatever you erased for the inner function, that should be replaced with the variable x for the outer function. That's it. So have fun doing them in the exam. I love this. It's decomposition. Any question? Any comments? So with this, you're done with section 12.1. So you have a homework for next Tuesday, 12.1. And now we are going to do inverse, but before that, let me do your exam.
Sure, I do my exam because we can't take the exams, right?
You can take the exam, no
Oh,
problem.
All right.
Lola. Leonardo. Ethan. Brian Lee. Lady absent. Anastasia absent. Azmahin. Reina. Samantha absent. Nicole absent. Michael. Fatimata. Brian R. absent. Brenham. Juwin. Ashley. Kathleen. Shahana. Priya. Ryan absent. Mariana. Yolisa. Alex. Andrew. MD. Chloe. Danielle absent. George. Highest is 108. George got 108. And now your quiz. George, again. Danielle absent. Envy. Quiz. Fatimata, she just left. Writing accent, employee accent, chewing. Alex. Ajmain. Rena. Ethan. Jonathan absent. Queen. Hannah. Please go. Elisa. Leah. Leonardo. Brian R. absent. Samantha absent. Ashley. Lola. Andrew. Brennan. Michael. Brian V. Cynthia. Danielle. Patalaka. That's absent. Are we gonna close next month? Please stay. I'm gonna give you on Friday instead of Tuesday.
And it will be on the chapter now.
I will post the solution of the exam. So once you look at it, if you have any question, we can go over the question in our next class. Calculator. Yeah. No problem. Let me go to. If you go to Brightspace, you can see I posted a calculator. So in order to use this calculator, you have to have the Excel download or installed in a device. Once you click on it, you can download it and then you can play with it. Now to play with it, you need to score from MyMathLab. So I'm going to go to MyMathLab. Okay. So once you install, the calculator will looks like this one. Here you have attendance, homework and quiz, exam 1, exam 2, exam 3 final. So we have exam 1 and 2, and the homework and quiz for now you're going to get them from MyMathLab. So attendance, I will count 22 days out of 28 days. So you have 4 excused absences plus extra 4 more. Not 4 more, 2 more. Okay. So let's say you attended all days, all 22 days. And then let me see, Who would like to pull up their MyMathLab score? Any volunteer? Let me see what did Ethan do. Not Ethan, sorry. George do. George. Okay. So to get the score, you click on the calculation. I mean, I don't know how your one looks like, but for me, this is what I see. Either you can get the score from here or you can get score from Brightspace. The total homework score, total quiz score. I actually don't look at the Brightspace because they update, that it takes time to update your score, whatever you do in MyMathLab. So the raw score is 140 for now out of 250 because we still didn't do chapter 12 and 13. So it's a good score actually. So you have 140 out of 250 and 87 out of 150. So 140, 87. 140 and then 87. Okay, and he got 100 in the first exam, 100 in the second exam, and he attended all classes. Right, George? You are never absent. Let me just make sure. George, yep, I don't see any absent so far. Like whatever I counted, there is no absent yet. Now you have to pass the final exam with at least 50. If you get below 50, nothing matters. You're going to get F anyway. So you have to at least 50. So if he gets 73 in the next exam and 50 in the final, then he will get 74. 74 means C. So obviously he's not looking for C, right? Because he wants to get A. His exam score is telling me he wants to get A. So let's say, even if he messed up the 73 and 51, if he do all homework with 100%, then see, he got, the grades went up. And let's say out of 150, he got 140 in the quizzes. See, even if he doesn't do well in the final or the third exam, he still can get a B- in this class. Now, if he did all of this correctly, how much exactly he needs to get his A? Let's say he got 80 here. It's 81. Let's say he got 90 here. It's 83B. Then final exam, let's say he got 70, 88, 80, 91. So if he improves this one, 95, he got 92. If he improves this one a little bit, it's not enough, so he needs more, 82. Ta-da, he gets his A. Okay. So you can play with this calculator and see, do you have any way of passing this class? Now let me calculate someone whose score is really bad, okay? Let's say that person failed both exam, let's say around 30 and let's say 34. So based on the exam score, definitely like 95 is kind of impossible, right? So let me fill this one also. Let's say you got 40. So if you get 40 in the third exam, and if you did all of your homework and then 140 in the quiz, then you have to have at least 80 to get 60 in the class. 60 means D, so you pass. At least you pass. So even if you fail all 3 in class exam, as long as you have very high score in the MyMathLab and you do well in the final exam, you still have a way of passing this class. But do you think you can get 80 by failing all the in-class exam? So is it realistic? Ask yourself, like, realistically, is it possible for you to get 80 in the exam, in the final exam? Final exam will be cumulative, means everything from day 1 to the last day of the class. So if you think, you know yourself better, right? So if you think you are not a hardworking person, then probably dropping would be a good idea for you. Now let me see.
Everything.
everything,
Final exam
everything.
is the hardest one out of like all these four, exam 1, 2, 3.
Yes,
Okay.
but I am actually giving you all the questions in the final exam little by little.
Oh.
So do you notice during every lecture I said, this will be in the final, this will be in the final. So I don't make the final, but based on the trend I see in the last few final exams, I can guess what kind of questions they'll put in the final exam. So if you study all those questions I mentioned will be in the final exam, that means you know what will be in the final exam. So all you have to do is remember them how to do them correctly. Alex. The in-class exam review sheet will be the review sheet for the final. So the review sheet for the in-class exam are based on the final exam questions. But it has more questions than what you have in the final.
Are the quizzes just like?
The in-class quizzes I'll add with the my method quizzes. So whatever you do here, everything will be counted. Okay, so you have time till you have 5 more days to think about your future. Do you want to keep staying? If you're a hardworking person, actually it is possible. I know realistically I've seen few students in my life. They failed all in-class exam, but at the end they're like, oh man, I'm screwed up. Like they studied really, really hard and they got 100% in the final. Just like a miracle, but it did happen. The past. So if you think you are like those very hardworking student at the end, then you have a chance. So I'm not telling you to drop. You know yourself better, okay? Better than me. So ask yourself, is it really possible for you or not? Any question? And the calculator is in white space. No question? Then you're starting 12.2. Another fun section. 12.2 talk about inverse function. What does inverse function means? Inverse function are actually the type of function who are reflection of one another. For example, if we have, let's say, one function is going this way, then its inverse function will be this one. So how is the reflection? You may wonder, right? What type of reflection it is? The reflection is here. If this is the mirror, then whatever you see in one part of the mirror, we are going to see the same thing on the other side of the mirror. So inverse function, they reflect about y equals x lines. This is too light. I'll make it dark. So two functions, the inverse of one another, if they are mirror of one another with the line y equals x. And what's the relationship between them? The relationship between them is that the x values, which is the domain, so if this is f, this should be inverse. The inverse we represent with the -1 power. But -1 power doesn't mean 1 over thing. It's the power only on f. So if you have f inverse of x, this is inverse function. But if you have f of x, whole thing with a -1 power, then it means 1 over f of x. It's a fraction. So they are not same. The inverse only can happen, the -1 only be on f. But to have a fraction, everything is still the negative power. Now, the domain for your f function will be the y values, which is range of your inverse function. All the x values you see in the f function will be all the y values in the inverse function, and vice versa. whatever we have the y values in the, which is range, in that function, they will actually be the x values, which is the domain for the inverse function. So range is the original, turns into domain for the inverse. And domain for the original turns into the range of the inverse. So they're opposite of one another. Not opposite, like, what was I can say? They flip, they reverse. The reverse of one another. Domain for original is the range for the inverse. And range for the original is the domain of the inverse. So if you have a point, let's say here, if this point is -1, +1, the same exact point will be here, +1, -1. You see, the reflection of this point could be here. So that's the relationship between inverse and the original function. Now, few more ideas. For example, if you have a bunch of relation, like bunch of ordered pair, how do you figure out whether they represent a function or not? Oh, when you have a function, there is also another type of function, one-to-one or not one-to-one. Do you remember the criteria to be a function? What was the criteria to be a function? What cannot be repeated? X value. So to be a function, let me write it somewhere where. Let me write it here. To be a function, actually no, never mind. Let me take a page here. It's not page break. Where did my page go? Okay. To be a function, x values cannot be repeated. To be a one-to-one function, both x and y values cannot repeat. Let me make it bigger. Repent? I said repeat, not repent. Repeat. To be a function, x, v-a-l-u. See, they don't even understand my handwriting. To be a function, x values cannot be repeated. To be a one-to-one variation, what is variation? One-to-one function. F-E-M-C. One-to-one function, both x and y values cannot repeat. Okay. Yeah. So the difference between function and one-to-one function is that to be a function, you cannot see the same x value more than once. But among those functions, if you want to be a one-to-one function, it means you cannot see same x value or the y value more than once. So for every one x value, you have only one y value. And for every one y value, you have only one x value. None of them can repeat. Now, based on this argument, we have -6, -6, 7, 7, 4, 8, 8, 4. So this bunch of ordered pair, do they represent a function? If it is, then is it a one-to-one function or not? Question number one, is it a function? Yes, because all the x values are different from one another. So it's definitely a function. Now, since it's a function, we can check whether it's a one-to-one function. So y values, -6, 7, 8, 4. Do you see the same number twice? So is it a one-to-one function? Yes. 1-to-1 function. This 1-to-1 means every x has every y, and every one x has every one y. So 1x to 1y, or 1y to 1x. This is what 1-to-1 means. Now about the inverse, there's a cool thing about the inverse. The cool thing is that if you have f of x equals y, so this is the original function. When you apply x in the original function, you get y value back. This is what it means. The input is x for the original function, it spits out the y value. Now the same concept we can use for the y, for the function, for the inverse. If you apply the inverse on both sides, then the inverse and f, they cancel out. You get x equals f inverse of y. What does that mean? It means the inverse function has input the y value and it spits out the x value for the original function. So whatever x value is for the original function, it's actually the y value of the inverse function. And whatever the y value for the original function, it's actually the x value for the inverse function. So x in the inverse is y for the original. That's why we have domain for inverse is range for original. Or domain for the original, range for the original is domain for the inverse. So x and y value, they switch their position. What does it mean? It means if you have, before this, let's do one more page. If you have example, f of 3 means 4. So here we have x value is 3, y value is 4 for f function. Right? Now the same story we'll see in the inverse. The inverse will have the other way around. F inverse of 4 equals 3. So here our x value is 4, y value is 3. So what do you see? X3 here is y3 for the inverse. Y4 here is the x value for the inverse. They switch their position. Now let's answer a few of these questions. We are given their function. The cubic function shifted 2 units up, x cubed plus 2. The first thing they want us to find is f of 1. So how do you find f of 1? If f is x cubed plus 2, what is f of 1? How do you find f of 1? 1 cubed plus 2, right? So 1 plus 2, which is 3. So f of 1 is 3. Now from here, even though they did not ask us, but we can figure out what is f inverse of 3. We have no idea what is the inverse function, but we do know that inverse function, when x value is 3, what would be the y value for the inverse function? 1. So if you know information about your original function, you have the information about its inverse. Now then,
Kind of like log. Like when you switch it around too.
Log and exponential. They are inverse of one another. The next one. They did not give us the inverse function, but they are suddenly asking, hey, find the F inverse of 10. So how can you find F inverse of 10? If you're finding F inverse of 10, how can you rewrite this using F function? F of what is what?
Okay, so now the x then, because before it was a y in the original function.
So our y is 10. So basically they are saying, hey, f of x is 10, find out how much is your x. So this is our f of x. X cubed plus 2. They are saying this thing is 10. Can you find out what's the x value? Basically, can you solve for x? What you can use logic. What number when you cube and add 2, you get 10? 2. So using logic, we know it's 10. So you're not 10, 2. But you don't have to use logic if you don't know how to use logic. You can use algebra. If you want to do algebra, then you subtract 2. So you get x cubed is 8. You take the cube root, and then you see your x is 2. So it doesn't matter what information they're asking us to find, as long as you know your original function or the inverse function is given to us, we can find the information about both the original function and its inverse. They are closely connected. One function tells us the information about the other function. The next one, we have f of x is x cubed plus 5. First, they want us to find what is f of negative 3. And then they want us to find f inverse of negative 22. So find the easy one first. Which one is easy to find? F of negative 3 or the inverse of negative 22? Which one is easier? Which one you are familiar with? F of 3, right? So your f of x is x cubed plus 5. Then what is f of negative 3? Negative 3 cubed plus 5. That is negative 3 times negative 3 times negative 3. Negative 27. Negative 22. So f of negative 3 is negative 22. And here, what they're asking us to find? Inverse at negative 22. So do you guys see the answer already, or you want to do some math? You don't see it directly, you do? If f of negative 3 is negative 22, then what about the inverse? What is f inverse of the negative 22? Negative 3. See, the x value here will become the y value here. So you're looking for the y. This x will be the y for this one. So answer is negative 3. This x will be the y for the inverse function. So if you find one, the other one, you get the answer automatically. Any question? If you find this complicated, then this will not be in the final exam. but I might give you this in the exam. And this is definitely in your MyMathLab. So practice with MyMathLab. Probably it will be easier for you to understand. Now, how do we find the inverse function? We found inverse when, before finding the inverse, from the graph, how do you figure out where there's an I should write one more line. No, I should use my pad so that it stays. Not every function has inverse. Only 1-to-1 function have functions. But what? Come on, I didn't know this. You know what? It's better to type than doing this. Not every function has inverse. Only 1-to-1 functions have inverse. That's why we care about 1-to-1 function, because only they have inverse. Now, if you don't know whether it has an inverse or not, based on the function, but you do know their graph, then from graph we can easily find out whether a function has inverse or not, or whether the function is 1-to-1 function or not. So from graph to figure out whether it's a 1-to-1 function or not, we do horizontal line test. You draw a line horizontally through your graph anywhere. If the line intersects the graph only once, then it's a 1-to-1 function. 1-to-1. How did you test the to be a function or not? Do you remember? Vertical line test. So with the vertical line test, you find out whether it's a function or not. If it's a function, then you check whether it's a 1-to-1 function or not. So the next one, is it a function? The V, is it a function? It's a function because it passed the vertical line test. But if you do horizontal line test, it's not 1-to-1. Not 1-to-1. That means this graph doesn't have an inverse. How about the next one? It looks like a cubic graph shifted down. Is it a function? It's a function, definitely, because of the vertical line test. But is it a 1-to-1 function? You can draw a horizontal line anywhere. So you say it is a 1-to-1 function. The last one. Is it a function? Yes, it doesn't matter where you draw a vertical line. It definitely is a function. But is it a 1-to-1 function? No, it fails here. 2 or anywhere here. It's not 1-to-1. Now this is an interesting one. Let me draw that for you. Example. What's it called? Okay. This graph. Is it a one-to-one function? I mean, is it 1-to-1 function? That's the trick. Is it even a function? So even though it passed horizontal line test, but does it pass vertical line test? So just because you see the word one-to-one, it doesn't automatically count the horizontal line test. Whether it's one-to-one or not, it comes later. First, you have to check whether it's a function or not. I remember giving this question last year exam in my 1030 class. And they all said it is a one-to-one function. And I was like, seriously, like, it's not even a function. So don't get tricked by this type of question. It's not even a function. Then how can it be a one-to-one function? Definitely no. No. So let's stop here. Tomorrow, not tomorrow, next class, we're going to do one more. And then we're going to learn how to find the inverse function. So don't forget to do your homework. And I open all the previous homework again till 10th. So if you missed anything, please redo them. And I just found out that if you do them after deadline, then they take 10 points off
For
each.
You know how many absences I have?
Brennan. Okay, I'll see.